Good afternoon and a warm welcome from a chilly Johannesburg. Welcome back to Bite-Sized Corrosion. And today we're going to continue unpacking the NACE standard SP 502 on ECDA, and we'll be focusing on the second stage of investigation called the Indirect Assessment. We're welcoming Frances Bradfield back with us today as the convener of the CEOCOR Working Group on Overline Surveys. She's really well placed to chat with us in this indirect assessment discussion. Just to quickly recap what we chatted about last time, ECDA is a really useful technique to help us in pipeline integrity management, particularly for pipelines which are not peggable. And last time we discussed just how important it is to gather as much information as possible. The physical information about the pipe, its size, its coating, its year of manufacture. Operational data such as periods when the CP system may not have been working, when there's been a leak, operating temperatures if it's a high temperature line. And corrosion data is also very useful, pipeline potentials, soil resistivities, and so on. And this whole data gathering exercise is known as the pre-assessment stage in the ECDA process. And it's absolutely foundational to ensure that we get a clear picture of what we know and to prepare us for the indirect assessments, which we'll be discussing today. So essentially, at the end of the pre-assessment section, we have gathered various risk factor data, and that helps us to determine what further data we need to draw meaningful conclusions about the status and condition of our pipeline. Fran, as we get started, when we talk about indirect assessment, what exactly do you mean by indirect?
So as you introduced with, there's many different processes here, but our indirect assessment is anything we can do to check our pipe without physically checking the pipe. So without physically going down and looking at the pipe with our own eyes. So we need to check other parameters that we can to see whether or not we are protected or whether we're concerned or whether we're not concerned, for example. So it is basically everything we can do within our power without actually digging up the pipe.
Okay, well, that's made it really clear. Thank you. If we get the information, and this is an extract from the NACE standard, this is the flow chart for the indirect assessment. So I think it's helpful perhaps if we have a look at this flow sheet and we talk through it. Fran, would you like to guide us in that?
Yeah, sure. So basically from our pre-assessment, if you remember, we looked at all of our history and took our good old boys to the pub to get their remembrances of what happened on this pipeline in 1936, maybe a little bit older than that, 1960 maybe. And we've checked out all of the data we had, and we blew the dust off all our old maps and all of that kind of thing. And we've gone through and we've come up with a sort of matrix of what information we have and where we have it for. So in our pre-assessment, we looked at it and we thought, well, where do we have gaps? What do we need to know before we can start digging up the pipe? Once we've got that data, we can then go out and perform our indirect inspections, like they say 4.2, and then we can collate all of that information and put it together for our direct assessment later on.
Great, I think that's really helpful. So let's have a little bit of a further look at exactly how we do it. We've got a little timeline here, which I think helps us through the process. We know that that's where our pipeline runs. Let's look a little bit at the terrain.
Yeah, basically this is my little imaginary pipeline of something I could expect. Actually mirrors quite a lot of something that we've done before. We have all these different things between our factory and our whatever it is along the pipeline, and it can be 1 kilometer long or it can be several hundreds of kilometers long. I think we all know about NMPP, for example. It's a very long pipeline and with many, many different obstacles that it overcomes. But here we can see we've got a pipeline. This also ties directly into our pre-assessment. We have a pipeline and it's crossing different obstacles. A road, there's a high mountainous area, another large road, a city, some kind of outdoor area, a train, whether we're going parallel to it or crossing it. We've got another city and we've got a massive highway right before our endpoint. And all of these things limit the data that we can get because some of it is impossible to get, and also change what ranking we give that section. So again, like we discussed, if it's next to a school, it's probably more important than something in the middle of a field where you're going to upset a few cows. So this is basically something that we just quickly made, which is where we've got our potential monitoring data, for example, at the factory. It's very good. They've got it online all the time because that's where the CP system is. We have soil resistivity data, but it's really low, so it could mean that we have a high issue with corrosion there. We also know that it was rewrapped in 1968 or whatever. And as you see, going along for each individual section, for example, here at the high altitude, we only have soil resistivity data because it's very difficult to get there, perhaps. Maybe we can't do a SIPS DCVG or a straight current survey. So we have very limited data there. And as we know, getting data in urban environments is also quite difficult. So something for us to remember, in order for us to be satisfied with the data that we have from the pre-assessment, we need to have 3 different types of surveys. It's not enough to have 4 years of potential data. That's not good enough. We need to verify it with some other factor. So for example, potential monitoring data, that's great. That could be somebody going with a voltmeter, taking one potential and going away, or it could be a slightly longer logged period, but that only tells you the potential at that test post. In order for us to know what's happening around there, we might do a SIPS DCVG, for example, to see if we have any defects and to see what the differential potential over the whole section might be. And then we would have the soil resistivity. And so right here, we've got a really low soil resistivity, for example, at the factory, but we've got good potential monitoring data. If we did a SIPS DCVG, we might find that there are no defects, and so that could be a good indication for us. But like you see here with the ticks, there are certain locations, like the second road, like the country lane, and at the final terminal, where we have enough data for us to be happy. It's not that the data is good, it's that there is enough points of data. So that might be a little confusing with the 2 sets of green. But even if everything was terrible and we had reds everywhere, that's still valid data, and it can say that we know everything we can possibly about that section.
So it doesn't matter if the corrosion perspective of the data is good or bad, it's the fact that we have data available that I think is key for us to take away.
So of course here you can see that at all of the other locations that we do not have enough information to make that call, and that's where our indirect assessment comes in. You see also that at our highway that I made up at the end, we have a new section, we put in a diversion, and that new section could be very recent, within say the next 5 years, in which case it's generally will only be investigated in the next ECDA cycle. So if it's brand new, we know the status as is now, and we can now include it in our monitoring plan going forward. So I wouldn't include any more surveys on the new section, presuming that we have some commissioning data, which we should.
That's really helpful. Thank you. This is real data from a combined SIPS DCVG survey. Would you like to talk about what we see here?
Yeah, so basically this is a combined SIPS DCVG, which means that we're walking around pipeline. I know you guys did a seminar, and I'm sure you can find it on Teachable to sort of see how we do the survey. But the idea behind a SIPS DCVG is we are connected to the pipeline and we walk over the pipeline completely, and we get a map of the potential and a map of any defects that we might find. So here you see at chainage 240, for example, we have a defect. This is a classic defect indication. We have a decrease in potential followed by an increase in potential. But what we see here is that it's quite a large, in terms of lengthways, potentially defect. And we are impacting, if you look at where it says mobile 2 at the top and mobile 1 at the bottom, you can see that we're pushing the potential slightly positive as we go through. And where we have our off potential, we're sitting on a borderline. So this is a defect that is not completely protected. And so we might be slightly concerned about it. So it's one to put a pin in and tie this up with other data that we have. It could just be that on this day we had low potentials for some reason, and at other times we usually have high potentials, in which case we'd be happy that that was protected, but we're not 100% sure. So that's one of the kinds of defects where we would need to verify whether or not we're concerned about it. Our second defect happens to be sort of in the middle here at about 600, and you can see that the potentials have drastically decreased to the point at which they are no longer protected.
Yeah.
And we have two very nice defects within that, just immediately at that. I think that that is probably somewhere around a road crossing, so that's even worse because we have an unknown in terms of soil resistivity and soil conditions, plus low potentials, meaning that our defects are unprotected. And so that's really one of the ones that would come up as a red, very concerned location. And then the final one is a very large defect, and it is also unprotected. So that would be 3 locations where we're a little bit concerned about what's happening there. And we would need to use this with the other data that we have to make a final decision whether we, for example, look at all 3 or whether we only choose the 2 very low protection areas.
I managed to pull out another example.
This is a lovely one. This makes everybody smile when we see something like this. There's a defect, so we found it. That's the first positive. The second positive is it's protected, and it's protected on both on and off potentials. And so the CP is doing its job here. So this is also a nice potential dig location, not because we're expecting to see a giant hole with petrol leaking everywhere, but quite the opposite. We hope to see verification that our CP system is in fact working, and that any other defects, for example, like this or anything else in that area, even if there's a defect, we are going to assume that it is protected. So this is another place that I'd be quite keen to dig up to check 100% we're in the clear here.
Super. Thanks, Fran. I think it's also important that SIPS DCVG, although very useful because as a combined survey, it's combining 2 completely different techniques, being the potential survey and the DCVG survey in one big walk across the pipeline. But there are other survey techniques that can be used. And I've managed to find some data from a stray current survey that we did, just to show that there are some points where we need to be a little bit cautious. So this is the first location that I found. Any comments on this? And this is real data, it's not fabricated. It really did go.
It's not fabricated. And it is in volts, not millivolts. Unlike where I'm sitting over here in Europe, people think I'm crazy when I say things like volt on the pipeline, but there we go. While this isn't good, as you can see, it's not stable at all. We are going negative, which means we're not forcing millions of electrons out of our pipeline, which again means that we're not actively corroding the pipe. I will mention, however, that I'm sure we've all heard of overprotection. We're not keen on having huge overvoltages on pipelines. We can get hydrogen embrittlement, for example, or disbond our coatings. So it's not a great thing, but it is better, at least, than having a whole lot of current coming out. And I presume you have another example where we're very worried about the pipe.
I do.
Yeah. And here we go. We're looking at very positive excursions here. And we are not protected at all. As you can see, red line is protection. So in general, we're not even protected over there. Here we are actively corroding our pipeline if there are any defects. And we need to sort these excursions out as easily as possible. So areas in which you have positive excursions in your straight current survey are big issues if you have the other risk factors. I would also hesitate to say, because I don't like the idea of saying dig up everywhere, but digging up, if you know that you have a defect in an area with negative excursions, you could check the extent of the cathodic disbondment.
Yes.
Again, it's not as bad. So if you have 50 Rand and you need to make that cover your defects, and this is definitely not going to cost you 50 Rand, then we put the money where we need to put the money. We got to rank them as well. It's not only dig everywhere, it's where's the most important, coming down to the nice to have.
And I think it's also important that we do, as you said, with the SIP survey as well, we do sometimes excavate where we do not anticipate to find a defect or damage to the pipe to prove the model, so that we can with greater confidence say that anything that meets a similar criteria can also be assumed to be in a similar condition.
Exactly. So this goes back to the idea of zoning, which we discussed last week. Because we cannot dig up everywhere, we do need to choose locations that we expect to be like the other ones. So where we expect everything to be fine, we should verify that it is indeed fine, so that all the other locations that are similar, we can, with clear conscience, say they're fine without digging them up.
Fran, there's of course other surveys that can be used, and I think it's worth not discounting surveys such as the soil resistivity to give us data for our indirect assessment stage.
Precisely. I think if you were to think back to the small schematic that we did, in the area that's very high and mountainous and rocky, for example, we know, and we would know because we would do our soil resistivity surveys in the beginning, which is how they would know where they need to blast rocks and how they're going to install the pipeline in the first place. We would know what that soil resistivity is, and chances are it's extremely high. And if we can use that, we look at it practically, we won't have much corrosion at all going on in that kind of location. And not only will, for example, digs be extremely difficult up there, it's very remote, all these kinds of things, it would probably not be necessary because of this very high resistivity. So something incredibly simple that's done at the very beginning of a project, maybe not even by corrosion people, maybe only by the geotechnical guys, really can be useful. And that's something, again, within our pre-assessment, you might be surprised that you could find this data from the initial geo-surveys for the pipeline. But again, it's a nice additional survey to help you make your decision if you're sitting on the fence between two locations.
And I think also it's worth noting that in a ranking scale, this is one of the less expensive surveys to conduct. And so if you don't have sufficient data, quickly doing a soil resistivity survey is practical. Quickly doing a SIPS DCVG survey is not practical.
No, as anybody who's ever seen a team of people doing SIPS DCVG walking down the road, not only do you look like aliens, but it really is like getting to space sometimes to get that survey sorted out.
Yes, I didn't put in photographs of the SIPS DCVG teams, but as Fran said earlier, if you go back and watch some of the survey techniques that we presented in our summer series last year, you'll see what we mean. So Fran, now we've got a whole lot of data. We can now start drawing some conclusions, which I think is where we're wanting to get to by the end of this indirect assessment stage.
Precisely. So here we have our regions that we previously identified within our pre-assessment, and we've now filled up the additional studies that we needed. So where we only had potential measurements, we've now also done a straight current survey. We've got resistivity data and SIPs with defects, whether or not they are protected or unprotected, because of course that's very important. So as you can see here, you've got type 1, 2, 3, and 4 defects, with 1 being safe and protected, 2 being safe so long as the CP system is functional, 3 not being safe even when the CP system is functional. And I think type 4 is just protected both. So type 4 is a negligible one here, but that's sort of beside the point. So we've got the varying degrees of concern and each different survey or data type. And so we take the varying degrees of concern for each type and the different types, and we weigh them. And when we've done that, we can come up with the places where we know we absolutely need to do an excavation. It's important to note again that, unless I'm mistaken, we must do 1 excavation per zone. Even if you have 5 zone A's along your pipeline, you only have to do 1, but you have to do 1, even if that is the protected area. If you have 5 protected zones, you do still have to dig up in one of those 5 protected zones to verify that it is indeed okay. So over here in this table, for example, each one of these at this corner, at that road, whatever, adjacent to the highway, every single one of those zones will have 1 dig up location. And I think it makes the most sense to excavate where you know there is a defect. Firstly, you can fix the wrapping. And secondly, you can see what the status of the pipe is at the defect.
At its worst, or most likely to be the worst condition.
Precisely.
Super, thanks, Fran. I think that's been quite helpful. Let's just go back to our spreadsheet from the NACE document. So we've now spoken about having performed the indirect inspections, and we've identified and aligned our indications in the table that we've just looked at. And in this table, then we can look at them, compare them, and prioritize which ones we want to excavate and those that we don't believe are important to excavate at this point.
Yeah, I think it's a good time at this stage, after you've done your indirect assessment, to remember that it's possible you have done an ECDA or something like it before. So any digs that you've done before is very worth bringing up to your mind, at least at this stage. We know we have a defect and it's borderline, but it's been that way for 30 years, and we've dug it up 4 times, and every single time it's been fine. We might not need to do that again. And we might put a peg in it for next year in case something changes with the potential, or we get a new pipeline or some more interference or something like that. So it's all about being a little bit practical here. We really have to look at the budget you have. We have to look at the number of indications you have and how severe these things are, or whether you just like to have the additional dig. But I think asset management is all about saving money. And so we don't want to dig where it's unnecessary. We want to do the bare minimum, but still get the most out of the survey.
Thanks, Fran. I think tomorrow we'll go in some more depth into the direct assessment stage and some very practical aspects of it. But I think it's really worthwhile to just consolidate what we've discussed, is that we have gathered our historical data. We've now identified additional data where we decided we needed it. And so now we really are at the point of being able to say, yes, we do need to dig in these 5, 6, 10 locations. And that's going to be the expense of the dirty and the validation stage to prove what we have been done. We're kind of testing our hypothesis. Were we correct in what we assumed we would find? And if we are, then we can apply that assessment throughout our pipeline and determine which sections might need to be replaced or rewrapped in a bigger quantity than just these 6 or 10 identified locations.
And I've been setting you all up for this. It's your indirect inspection today, and tomorrow it'll be direct inspection when you can see my face, and I've sorted out my camera issue.
That'll be lovely to be able to do that. I do see that we do have a question. It actually pertains to the zones. And just very quickly to end up, what if one of your zones is underwater? So your pipeline actually goes through water, and we really don't want to be digging, obviously, in water, because that's quite a logistical nightmare. We can, of course, get our indirect assessment data, can't we?
Yeah, actually, somebody posted something doing a SIP survey on a boat on LinkedIn recently, and it made me smile because the corrosion engineers are always in the deep end, and they really were. So off they go in their boat to do a SIP survey. And I think that will give you, obviously, as we discussed, a good idea of the potential and whether or not you have defects within that area. We can also check for stray currents. So we've got SIPs, we've got DCVG, we've got stray currents, and obviously the potential monitoring that we can do. But if we're still not 100% sure, we know that the resistivity of the water will be very low, but we can do chemical analysis on that water to see if it is very acidic, for example. If it's a bog marsh or something, then we could get a bit concerned, and maybe as a last resort we could consider a diver or some kind of ROV, for example, a remote operated vehicle. But really we want to try and avoid that. Similarly, if you have an area of concern underneath a large road like a highway, we would really prefer not to do that. So we're going to get as much data as we can otherwise and try and make educated decisions on that basis.
Well, thanks, Fran. I think that was helpful, and I hope it's adequately answered the question. And as we end off this afternoon, I just want to thank everybody for taking time to join us. And we really hope that you found it to be a valuable conversation, and that you will join us again tomorrow as we continue this discussion and look at the direct assessment methodology and some very practical tips on what works, what doesn't work, what to do, and so on.